In this problem, we are going to discuss how to graph an inequality on a one-dimensional number line. We're going to start by looking at the inequality. What number are we referencing here? We're referencing a -3. The next thing we're going to look at is the inequality sign. If there is a dash under the inequality sign, we're going to use a solid circle on that number. If there's no dash under the inequality sign, like in letter B, we would use a hollow circle, and I'll show you in that example. But in this current example, we have that dash indicating that x is greater than or can equal -3, so we're using a solid circle here. Next, we have to figure out which way our line is going to point. To do this, I like using test points and putting them into the inequality and seeing if it creates a true statement. So if I look at the number to the left of -3 and I put it into the inequality, is -4 greater than -3? No, it is not. So we know that our number line is going to go the opposite direction. And if you're unsure, you can always test any number to the right of your indicated number from the inequality. I could choose 2. Is 2 greater than -3? Yes, it is. So we know that our arrow is going to point to the right. Next, we have to write this inequality in interval notation. Our number line is going to help us out with this. Whenever we have a filled in circle, we're going to use a square bracket. When we write in interval notation, we always start with the leftmost number and go to the right. Just like how you read, you always go left to right. So we can start with -3. We use a hard bracket because x can actually equal -3 in this inequality. Then we use a comma and see how far to the right our arrow goes. In this case, it goes on forever. So we can say that x can approach infinity. It can go really, 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 really high. There's no limit. So we can put infinity as our other endpoint. Now, infinity isn't a number, it's a concept. So we can't use a hard bracket on infinity because x can't actually equal infinity. X can only be a real number. So whenever you see infinity, or in later examples, -infinity, we're going to use a soft bracket or a parenthesis to end the statement. In letter B, we have a straight less than sign. There is no dash underneath indicating that x can actually equal 2.5. So I'm going to start by graphing 2.5. So I'm going to use a hollow circle because x cannot equal 2.5. Now I can look at my test points. I'll choose a number to the left of 2.5. A really easy one to use would be 2. Is 2 less than 2.5? Yes, it is. So I know my number line is going to be going towards the left. Now, how far to the left does it go? It never stops. So in this case, we start all the way at the left by notating -infinity, the concept of -infinity. Again, soft bracket on that because x cannot actually equal -infinity as it is not a number. Then comma, we go all the way up to, but we never actually touch 2.5. Because we don't touch 2.5, x cannot equal 2.5, we have a hollow circle on 2.5. We're going to end this with a soft bracket or a parenthesis. In our last example, we're going to start by plotting -35. We have a dash underneath our inequality, so we know that x can actually equal -35. So we're going to use a solid circle. Then we're going to use our test point. I'm going to look to the left of 35. You could also look to the right of 35. arrow is only going to point in one direction. So if you're right, you go in that direction. If you're incorrect, you go in the opposite direction. I'm going to test negative 36. Is negative 36 less than negative 35? Yes, it is. So I'm going to be pointing my arrow to the left. So just like in the previous problem, x can approach negative infinity, the concept, soft bracket, and can go all the way up to and actually equal negative 35. So we're going to use a hard or square bracket there.